So welcome to this session on IDFT using DIT-FFT technique. Already we have studied how to find DFT using FFT technique. So how to find DFT? So by using DIT-FFT technique, DIT-FFT technique. So that is nothing but flow graph. Okay. So in that case, we have seen how to calculate 4-point DFT as well as 8-point DFT. Now today we will see how to find IDFT by using IDIT-FFT technique. IDIT-FFT technique. Now see, in case of inverse DFT, while finding inverse DFT by using inverse DIT-FFT technique, DIT-FFT flow graph. Now what is the change? You have to use the same flow graph whatever used by you. So here we are going to discuss 4-point inverse DFT, 4-point. So in case of 4-point, the flow graph will be like this. Flow graph. So those two are connected, then this is connected. It is -1, -1, -1, -1, and this is -j. Correct. So this is the same flow graph we are going to use for IDFT while calculating the inverse DIT-FFT or inverse DFT with some modifications. So what are the modifications you have to do while using it for inverse? So that is nothing but towards input, what will be input now? It is x of k, and what is the output? It is x of n. Means frequency domain representation will be as a input and output as a x of n, that is nothing but time domain representation. Now in case of this flow graph, in case of this ID or DIT-FFT flow graph, inputs are out of order and in output is in order, so that we will get x of 0, x of 1, x of 2, x of 3, and output is out of order, input is out of order, means x of 0, x of 2, x of 1, x of 3. Correct. So this is the first change. Input and output relation will be changed. One more change is you have to take input as a complex conjugate of the number. So whatever number, you have to take complex conjugate of it, complex conjugate of each one, and output also you will get in terms of complex conjugate. So what is meant by complex conjugate? A plus IB, the complex conjugate of it is the real part sign will be same. You have to change the sign of imaginary part. So if it is plus, it will become minus. If it is minus, it will become plus. So that is nothing but complex conjugate of each other. So that is only the change. And third change is you have to multiply by 1 by 4. In case of 4-point, 1 by 4. 1 by 4. So this flow graph we have to use for calculation of inverse DFT by using IDFT technique. Same flow graph, only with some modifications. Input will be as a x of k, means a frequency domain representation. Output will be time domain representation. Output is in order, input out of order. While taking the input, you have to take complex conjugate of the numbers. Similarly, output you will get complex conjugate. Then you have to multiply finally by 1 by 4. So that is nothing but DIT-FFT flow graph. And by using this flow graph, you can calculate inverse of DFT. Now we'll solve the problem. Find IDFT of x of k is equal to, find IDFT of x of k is equal to 17 minus 3 minus 2i, 1 minus 3 plus 2i. So write down first of all x of 0. What is x of 0? Is 17. What is x of 1? Capital X of 1 minus 3 minus 2i. Then what is x of 2 is 1, and what is x of 3 is equal to minus 3 plus 2i. Correct? Now find out the complex conjugate. So that represent it as complex conjugate of this one. As there is only 17 means it is real part, so that no change in the sign of it. Then go for next. Complex conjugate of x of 1 is, you have to change the sign of imaginary so that it will become minus 3 plus 2i. Then complex conjugate of this, there is no imaginary part, so answer is same. And complex conjugate of 3, that is equal to minus 3 minus 2i. So sign of the imaginary part will be changed. So this is nothing but how you can calculate the complex conjugate of it. Now use the flow graph. I will draw the flow graph for the 4-point DIT-FFT. Okay, then it is minus 1 minus 1. This is minus j minus 1 minus 1. Inputs are x of 0, then x of 2, complex conjugate of it, x of 1, x of 3. Output is, it is multiplied by 1 by 4, 1 by 4, 1 by 4, 1 by 4, and it is x of 0, x of 1, x of 2, and x of 3, complex conjugate of it. Now put the values. The values are, what is x0? X0 is 17, so you can have the value as a 17. Second, x2 is 1, x1, so minus 3 plus 2i, minus 3 plus 2i, and x3 is minus 3 minus 2i. Now do the calculation as per our convention. You have to add at this location. Do the additions. See, 17 plus 1, 18. 17 minus 1, 16. Correct? Now here you have to add both. Minus 3 means minus 6. Then plus 2i minus 2i, so cancelled. So answer is, this get cancelled because of addition. Now here it is minus 3, so you can write it as minus 3 plus 2i, then minus multiplied to minus 3 plus 3, and then plus 2i. So answer is 3 get cancelled. It is equal to 4i or 4j. If it is j, you have to take it as a j. So everywhere it is, suppose j, as you are taking the j. Now it is 4j, correct? 4j. Now multiply 4j with minus j, so it is 4j multiplied by minus j. So it is 4 minus 4j square. What is j square? Is minus 1. It is equal to 4. So answer will be 4. Now do the next calculations. Minus 6. 18 minus 6 as a 12. Correct? Then it is 4. 16 plus 4, 20. Then this one 16 minus plus 6, 24. So it is equal to 24. Then 16 minus 4, so that is 12. Now multiply by 1 by 4. So 12 divided by 4, 3. 20 divided by 4, 5. Then 24 divided by 4, 6. And 12 divided by 4, 3. So what is the answer? If you take, this is a complex conjugate. Even if you take x of 0, because there is no imaginary part, so answer will be 3. So x of 1 is equal to 5. X of 2 is equal to 6. And x of 3 is equal to 3. Okay. So answer is x of n, we got it as 3, 5, 6, 3. 3, 5, 6, 3 by using inverse DIT-FFT flow graph. I think you have understood. There are few changes. By using that changes, you can calculate the inverse of this one. So how to find the inverse? First of all, write down the x of 0, x of 1, x of 2, x of 3. Then write down the find out the complex conjugate of it. Complex conjugate means the sign of imaginary part will be changed and real part sign will be same. So if suppose it is a plus ib, this is real part of the number, this is the imaginary part. So you have to change the sign plus to minus for finding the complex conjugate. Then write down the numbers, do the calculation as per our conventions, and finally get the output. That is nothing but how we will solve for the inverse DIT-FFT. Okay, now next point of discussion, that is circular convolution using FFT flow graph. Already we have found out circular convolution by using DFT, means by using matrix. Now in this particular point, we will discuss circular convolution using FFT flow graph, how to calculate it. Now question is, see the question, find circular convolution of x1 of n is equal to 1, 2, 3, 4 and x2 of n is equal to 5, 6, 7, 8 using FFT IFFT technique. First of all, write down x1 of n is equal to 1, 2, 3, 4 and what is x2 of n? x2 of n is equal to 5, 6, 7, 8. Okay, and we have to find this circular convolution of both using FFT IFFT technique. Now how to find the circular convolution? In case of finding circular convolution, you have to take x1 of n, then find out the FFT so that it will become x1 of k. Then x2 of n you have to take, find out FFT, that will become x2 of k. After finding them, multiply pointwise, multiply them. Then you will get x1 of k multiply by x2 of k. Okay, then find out inverse FFT, inverse FFT. After inverse FFT, you will get, this is suppose equal to y of k, so you will get y of n. So it is nothing but circular convolution of x1 of n, circular convolution of x2 of n. So this is DFT property, DFT property that we have discussed. In DFT or in FFT, the circular convolution in time domain will be simply as a multiplication in frequency domain. So that by using that property, we will find out the inverse, means we will find out the circular convolution of the numbers. How to find out the circular convolution? Take first number, find out FFT, that is the answer 1. Take second number, find out the FFT, that is answer number 2. Multiply 1 by 1, means pointwise, means first value you have to multiply, second you have to multiply, third, fourth you have to multiply, and after multiplication find out inverse FFT, and that is nothing but answer we have. So this is the flow graph. So you can write here using circular convolution property, circular convolution property. Okay, now we'll begin with this. First you can write x1 of n. What is x1 of n? 1, 2, 3, 4. Find out FFT of it by using flow graph. Flow graph, use the flow graph. The flow graph, draw it, minus 1, minus 1, minus 1, minus 1. It is minus j, x of, means it is capital X of 0, x of 1, x of 2, x of 3, and inputs are x of 0, x of 2, x of 1, x of 3. Okay, now I will take this as a 1, this is 3, write down here so that there will be no confusion. X of 0, x1 of x1, x1, x1. So it is x1 of 0, x1, this is x1. 1, x1 of 1 is 2, x1 of 2 is 3 and x1 of 3 is 4. Okay, put that values. 1 is 2 and this is 4. Now do the calculation. 3 plus 1 4, 1 minus 3 minus 2, 2 plus 1 6, 2 minus 4, that is equal to minus 2. Multiply this, it is 2j. Calculate 6 first 4 10, then minus 2 plus 2j, so it is 4 minus 2, this is minus 2 minus 2j. So answer for this one is x1 of k, we got 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So this is the first answer we got. Now similarly go for next. That is nothing but x2 of n. What is x2 of n given? 5 6 7 8. 5 6 7 8. So what is x2 of 0 is 5, x2 of 1 is 6, x2 of 2 is 7, and x2 of 3 is 8. Okay, now draw the flow graph for finding FFT. 4-point DA means flow graph for FFT finding. Minus 1 minus j. So it is x2 of 0, x2 of 2, x2 of 1, x2 of 3, and this is capital X of x2 of 0, x2 of 1, x2 of 2, x2 of 3. Okay, now put the values. X2 of 0 is equal to 5, 2 is 7, this is 6, this is 8. Do the calculations. 5 plus 7 12, 5 is minus 2, 14 minus 2, the 2j. Then 26 is equal to minus 2 plus 2j, 12 minus, it is minus 2 minus 2 minus 2j. So answer is x2 of k is equal to 26 minus 2 plus 2j minus 2 minus 2 minus 2j. So first step is over, that we have calculated the FFT. Now next step is you have to multiply both the values. Now find out y of k is equal to x1 of k multiplied by x2 of k. So here you have to multiply point wise. So what is 10 minus 2 plus 2j minus 2 minus 2 minus 2j multiplied by 26 minus 2 plus 2j minus 2 minus 2 minus 2j. Okay, so 10 into 26, point wise you have to multiply. Remember, you have to multiply point wise. So first value it is multiplied with the first, second with the second, third with third, so that it is 260. Then find out second multiplication. So minus 2 plus 2j multiply by minus 2 plus 2j, so is equal to minus minus plus 4 minus 4j, then minus 4j, then plus 4j square, so is equal to 4 minus 8j, this is minus 4, so answer is minus 8j. Okay, so next answer is minus 8j, then minus minus plus 4, and for last one the multiplication is, will multiply for next, that is nothing but minus 2 minus 2j multiply by minus 2 minus 2j. So answer is 4 minus plus 4j, then plus 4j, then minus minus plus 4j square. So answer is 4 plus 8j minus 4, so it is 8j. So answer is equal to 8j. Okay, 260 minus 8j, 4 and 4j. So this is multiplication we got. After multiplying, what we have to do? Find out inverse. Find inverse FFT. So how to find it? Y of k we got it as 260 minus 8j, then it is 4 and 8j. So that y of 0 is equal to what? 260. Y of 1 is equal to minus 8j. Y of 2 is equal to 4. Y of 3 is equal to 8j. Okay. Then find out complex conjugate of it. My y of 0 is 260. Y of 1 complex conjugate of it is 8j because it is imaginary part. Y of 2 is 4 and y complex conjugate of 3 is minus 8j. Okay, minus 8j. Now use the flow graph, 4-point flow graph. So here in input will be complex conjugate of 0 out of order, 2 complex conjugate of 1, complex conjugate of 3, minus 1 it is minus j, then minus 1, and this is complex conjugate of this y0, y1, y2 and y3. Then you can put the values as 260, y2 it is 4, then y star it is 8j, this is minus 8j. Okay, so do the calculation. 264, then 256 because 260 minus 4, 8j 8j, this is 0, 8j plus 8j 16j. Okay, 16j multiplied by minus j, so it is 16j square minus 16, so plus 16, so answer will be plus 16. So it is equal to 264. Then next is 256 plus 16, 272, 264, and last it is 256 plus minus 16, so 240, and it must be multiplied by 1 by 4, 1 by 4, 1 by 4, so it is divided by 4, divided by 4, divided by 4, divided by 4, so answer is 66, 68, 66 and 60. So that circular convolution we got y of n. Here complex conjugate, it is real number, so that complex conjugate is also same. So y of n is equal to 66, 68, 66, 60. So this is the answer for the circular convolution. How many steps we have performed? We have performed FFT of first one, FFT of second, then we have multiplied and then inverse. That is nothing but we got the circular convolution or the answer. Similarly, you can verify this answer by other method, but whenever they will ask for circular convolution by using FFT IFFT technique, you must solve by FFT IFFT techniques. So this is nothing but the property of FFT, or you can say DFT, and by using FFT IFFT technique you have calculated the answer. Okay, so this is nothing but how you can find the inverse as well as circular convolution by FFT. We can stop here.